Right, kites are a shape that you probably have not looked at too much, and maybe not trapezoids either. So let's start by writing down what the definition of a kite is. Kite. Kite is a four-sided figure. It has exactly two pair of congruent consecutive sides. So it's not the opposite sides that are congruent in a kite, it's consecutive sides. But not all consecutive sides. They pair up. There's two pairs. So as you notice in this picture, AB and AD are congruent, and then BC and DC are congruent. Because if all of them were congruent, that would be a rhombus. The kite is not a rhombus. It says a kite has one line of symmetry. What's that mean? It cuts it somewhere so that when you like fold the shape, both halves are the same. Can you tell me what segment or line would be the line of symmetry if I would draw it in? AC on this one, correct. Okay. And how did you know that? Probably looking at what sides match up. When you fold, these two congruent sides would match and those two would match. If you at least know that there's that line of symmetry, you can tell some things about the kite. Not only are those segments congruent, but there are some angles that are congruent. Which ones are we going to expect the same? Yep, angle B and angle D would be the same. And not angle A and angle C, but this little angle and this little angle would be the same when you fold it. And the same over here, this angle and this angle would be the same. We'll have to do some measuring here and see if angle A's total and angle C's total are the same. Because it is possible that those would be the same. I can't tell exactly from my picture. So we're going to try and create a kite and do a few of those measurements that we're not real sure of to see whether they are the same or not. Okay? So on your paper and in your notes there, I don't know, backside maybe, theorems say that you can think through. So if we have diagonals that are perpendicular, we can probably find some missing measurements using that Pythagorean theorem that we had a couple questions on homework about. So we're coming back to using the Pythagorean theorem a lot. Let's try a couple problems related to kites. Ready? I think you'll have to do some calculating for me. It says Daryl's going to make a kite. He wants to double all the measurements in the picture. What's the total amount of binding needed to cover the edges of his kite? Down to the nearest tenth. So what am I really asking? The perimeter is what I'm asking. So how are we going to find the perimeter? Well, first we have to double all the measurements. So let's kind of do that. This measurement is going to double to be 26, 32, 32. That's the one that's bisected. 24. And 44. You know, how are we going to find like this green edge? How are we going to get that edge figured out? Pythagorean theorem. How will we get PS figured out? And notice those two would be the same. And on the top, again, Pythagorean theorem, QR, and then QP. Okay, pick one of these, either the green triangle or the red one, and do the Pythagorean theorem for me. I have some cheapy calculators if you don't have anything. To the nearest tenth, now my policy is if it says nearest tenth, we're not rounding to tenths until we get to the final answer. So if you're going through the problems, go more than tenths. Go like hundredths in the problem, and then at the end is where you'll round to tenths. Okay, so pick either the red one or the green one, and let's come up with it. While you're calculating, I'm going to orient my screen. It's off a little bit. I'm having trouble writing. Hopefully you're looking and thinking, okay, hypotenuse has to be longer than the two legs that I used. So, anyone have the green RS? 54.4. How about the blue QR? I'm hearing two different answers. 41.2. So if we go with those numbers, add up, and let's see what our perimeter is. Now, a lot of you are not following the rule. I said go hundredths on those two. Okay. Let's see what we get. Question coming up with those? We're getting 191.3. We're probably not getting 0.3, are we? Getting 0.2. Okay, so that would be a matter of going to hundredths. So I have my solution on the next page. Okay, we said 54.4 and 41.2. Right. So it looks like when I did this, I didn't even go to decimal until the very end. So, and on one hand, I'd say I shouldn't do those simplifying. Got two of those and two of these, I guess. Alright, so it sounds like we did the right thing. We just went to decimal maybe earlier than what I had done in my solution. So try and keep it exact as long as possible. Okay, a similar kind of question. Lucy's framing a kite with wooden dowels. She uses two dowels that are 18 centimeters. Those went here. One dowel that's 30 centimeters. That was this brace. Two dowels that are 27. To complete the kite, she needs a dowel for KL. She has a dowel that's 36 centimeters long. About how much wood will she have left after she cuts the last dowel? So in other words, does she need all 36 for KL, or will there be some left over? So how are we going to work through this one? We're not finding the edge this time. It's still a kite. Those sides are the same, those are the same, diagonals are still perpendicular. We still have right triangles, but we don't know this part and we don't know this part. So it is related to Pythagorean theorem still, but you're not finding the hypotenuse. Okay, so pick one of these two triangles again. Oh, what are we going to use for the length here from M to the center point?
15.
15, because 30 was the whole distance. 15, 15. Pick one of the triangles, go Pythagorean theorem. How about give it to me in a square root? Square root of what? 549? For which one, X or Y? X?
Yeah.
Is he right? Square root of 549? Yeah? That's not a perfect square, is it? Okay. Y is the square root of? Anyone do the Y part? 504? Now that doesn't make sense to me. This one is shorter than X. Okay, I'm thinking X maybe isn't right then. One of these isn't right. Are you with me on my thinking? This doesn't make sense. Did you subtract 18 squared minus 15 squared? No? You added them?
Yeah.
Okay, let's get a different number then. 18 squared minus 15 squared. Square root of 99. All right, why am I doing the decimals? It's going to be more exact. Okay, take the square root of 99 plus the square root of 504. That is not the square root of those numbers added together. Okay. So what are we coming up with? I should grab a calculator and make sure you're giving me the right numbers. Got that in a decimal. And maybe I'm making this seem difficult to you. Square root of 99, parenthesis to end that, plus the square root of 504, end of that. I get that that's like 32 point, it would round up to 40. All right, so how much will we have left? The dell was 36 centimeters. So 36 minus 32.40 is 3.6. Yeah. Okay. Anyone having trouble operating the calculator? Now this one comes up with a parentheses when you start the square root, so you have to put a parentheses to finish the square root. Those little cheap ones, you're probably going to have to write down some decimal numbers earlier than what I was just doing. So document what you're doing so that we know that we're agreeing on the calculations. Okay, so kites, a lot of Pythagorean theorem because of the right triangles involved. How about angles in the kites? Now think about what we talked about. There were right angles. This angle on the left here and the right were bisected. I guess we never looked to see if this top one was bisected, but looking at my picture, does it appear that this diagonal cuts that in half? I don't think so. What can we do with angles? PQR is 78, so this part's 78. PRS, this part is 59. And we're supposed to find QRT. Did I kind of write that in the wrong place? Yes, I did. I was going to say, I found, they gave me what they're asking. PQR, okay. This whole angle, 78 degrees. QRT, you're supposed to find this one. Okay, what ideas are going through your head as far as kites and angles?
Is that 59?
That is a 59 there.
So what do you have?
Asking what angle QRT is.
59.
Because
And
does this diagonal,
QR bisected that.
so if I folded the kite,
Never mind.
it's folding the other way, isn't it?
Yeah.
Yeah. So
Q.
So that one's not bisecting it. But it's bisected this way, you say.
Yeah.
So the 78 is cut in half.
Yeah.
What's half of 78? 39? So this angle's 39. So this one, does that help us come up with the angle we're after? Tell me what you're thinking.
Like GTR is right angle,
Okay.
and it's 39.
It's 129. So then he's trying to do triangle something. So what do we come up with? A lot of mental math going on there. 51? Right number? Write it. 51 degrees. 51 and 39 is 90, and then the other 90 makes 180. Hendrik, did we blow a gasket there? You weren't with us, huh? All right, now I did a different way. If you kind of look at what my work was, this 78. Okay, let me get rid of all the scribbles from up in here. Okay, this 78, I did split 39 and 39. Actually, I didn't. Okay, if this angle's 78 total, then what did I do? I guess I did. 102 divided by 2. Sorry, I'm looking at my work. Oh, okay, here's what I did. Isosceles triangle. This great big triangle that I highlighted in green is what I did in the solution. 180 minus 78 makes 102 that needs to be split between these two base angles. That's why I have the 102 divided by 2. Okay, sorry. I had to think back what I did. Okay. I think we should go on to isosceles trapezoids and trapezoids before we run out of thinking time. Okay, trapezoids. So go back to your definitions. So the other shape for today is a trapezoid, and it's a quadrilateral with exactly one pair of parallel sides. It doesn't have two parallels, it just has one. Did a kite have parallels? No, it did not. There are no parallels on a kite. Trapezoid there is. And as far as terminology, the parallel sides are called the bases. So a trapezoid has two bases. The sides that are not parallel are called legs. The legs could be different lengths, they could be the same length. It just depends upon the trapezoid. Then there's also the term up here, base angles. Technically, any angle in the trapezoid could be a base angle, but when you refer to base angles, you pair them up. Okay? Base angles of a trapezoid are two consecutive angles whose common side is a base. So if I use the top base, the two angles that are at the ends of it, angle B and angle C, that is a pair of base angles. And then angle A and angle D, because they're on the same bottom base, those are a pair of base angles. Notice B and A, they have a leg that is in common, not a base that's in common. So those are not base angles. So what relationship do we have in trapezoids? Rather than draw and measure, let's just think about things we've studied. We have parallel lines up here. What can we do with parallel lines and a transversal? I erased it. We discussed that on the homework a little bit, homework question. What kind of angles would A and B be called? Say louder. Same side interior angles. Got parallel lines and a transversal. So if these are same side interior angles and the lines are parallel, what's the relationship with angle A and angle B? Supplementary. They would have to add up to 180. And the same with angles C and D. On that end, they would have to add up to 180. So we've got some that will be supplements. Other than that, the angles in just any trapezoid would be different. if it's an isosceles trapezoid, so here's another term to define. An isosceles trapezoid is one that has a line of symmetry. Why does it have a line of symmetry? Its legs are congruent. The legs are congruent, it's called isosceles, and you can probably tie into that term thinking about what an isosceles triangle was. Isosceles triangle had two sides congruent. An isosceles trapezoid has two sides that are congruent, specifically the legs. It does have one line of symmetry, and if you would go right down through like the midpoint of each of those bases and fold that trapezoid, the two halves would match up. So just thinking about what matches, wouldn't this angle be the same as this one? And those share the same base, so those base angles are congruent. And this angle and that one would be the same, again, base angles that are congruent. Add up to 180, being congruent, we've got a lot of angles that would match in there. So the theorems, there's actually 3 theorems these are all about isosceles trapezoids. There is no specific theorem about just a generic kind of trapezoid because there's no relationship that's always true. We don't have right triangles going on here. Keep in mind the symmetry idea. That helps a lot when you think about the isosceles trapezoids. That last theorem will be on tomorrow's lesson. So let's just look at a few examples related to our isosceles trapezoids. Got it? Okay. All right, that last one was a biconditional, so you can go forward and backwards on it. So angle A. What kind of a trapezoid is this one? It is isosceles. So angle A is going to be the same as angle, hold it the right way, B or D? I think I'm hearing D on some. B is the correct one. You would fold it horizontally. So A and B are going to be the same. C and D are going to be the same. What's angle A? Is that 80 degrees, correct? Because of your same side interior angle idea. JN is 10.6, NL is 14.8. 10.6, 14.8. What is KM? What about diagonals on isosceles trapezoids? They're what? They're congruent, so Lucas? I thought you had your hand up just a second. Hendrik. Okay, so what's KM?
25.4.
So just adding those together. Okay, this one says find the value of A so that PQRS is isosceles. So what would A have to be to make that trapezoid isosceles? So which theorem is this? Read your 664 again. Isn't that the one that ends up with an isosceles? If you can make base angles congruent. So which ones are base angles? P and base angles, they share the same base. P and S would be base angles. So we want to set those equal to each other. Now would you have trouble solving that? What would you do to solve? You said you wouldn't have trouble. Go ahead.
Okay, so you subtract 27.
Subtract 27.
Yeah. Maybe not. Maybe that's not what I mean. Scratch that.
Scratch that?
27. start over.
Okay.
Add 54 to the 27. Then subtract a,
Squared.
yeah, from 2a squared.
So that's gonna be 1a squared equals 81. 1a squared is the same as just a squared. How would we get a? We've been doing this Pythagorean theorem. How do you get a then? Square root, 81, which is 9. Now in this, it's kind of tricky. We could actually have positive and negative. How can you have negative 9 for a? Well, because you're squaring it. If you put in negative 9, when you square negative 9, isn't that positive 81? So when we substitute in, it will come out to be a positive angle, but a could be negative 9 also. Once in a while, they're throwing in where you've got more than one solution. So the answers on this one should have been 9 and negative 9. All right, look like we're running out of time. Isosceles. We'll do some classifying and constructions tomorrow. Just click and click to see what else there was. Okay, yeah, we're not going to get to those constructions. We did the kite, but we'll have to pick up those other shapes tomorrow.